Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. This little guy takes me back. I had one of these sitting around my house for about 3 years that a guy brought over and had me repair, and all it needed was a capacitor, and it was a $25 repair, and it sat at my house for 3.5 years. He finally showed up and paid me with a bag of Crown Royal. He had a bag, a little purple bag, and it was a Crown Royal bag, and it was full of pennies, nickels, and dimes. He owed me $20. And he paid me in pennies, nickels, and dimes. Never forget that little loudmouth. This is not that. This is been taken care of way better than what that was. The other thing was a butch job. This thing is actually pretty much stock on the inside. I gotta get in here. Oh, I love it. Love it. Reminds me of my youth. Taking apart stuff, trying to figure out why. Why is it no worky? Where did magic smoke come out? So the reason we're even on the bottom side of this thing, because it is in pretty pristine order, is this fuse holder here. I don't know if it took a bump in shipping or if it was broken before it was sent. But this old boy, he's called me a couple times now. Contrary to popular belief, I have quite a few amplifiers here I need to work on. It's like I got this one guy who's got an X-Force amplifier up here. He has called me 5 times in the last 3 days, and he keeps going, well, I'm worried my amp's going to not get repaired. I'm like, brother, your time is coming. I got a lot going on, you guys, on a lot of different levels. I've had a family almost tragedy at this point, and spending my energy on that. I got a kid that's been pretty sick here the last couple days. Got her into her pediatrician yesterday. Just busy on a lot of levels. My attention's all over the place. So I'll get there when I get there. What else can I say? And I'm not going to apologize for my family, taking care of my family. That's never going to happen. You're not going to get me to come out here on Front Street and do that. So this little fuse holder is garbage. Turn the video finder around so I can see what the hell I'm doing in camera here. Well, I know, young man. I got my dog out here. It's pretty early in the morning. I was so tired earlier. I just laid down and I had to take me a nappy. You know, old man nap. Well, the old man nap turned into about a 6-hour ordeal, and when I woke up I went, man, let's go out and let's get some stuff fixed. So because later on today I got to work on new build projects. I'm gonna have a couple things coming up for sale here pretty quick. Short order. So being tax time, I don't think we're gonna have a problem with that. We'll be able to find new homes for this stuff pretty fast. Now if I can remember where I put all my fuse holders, because I have literally dozens of them. Shada! Here we go. Let's see, what is the one that is technically closest? It'd be that one. Yep. That'll work. Why, yes, I keep like 12 different kinds of fuse holders in stock on the shelf right now every day. Just in case you send me your one, whatever it is thing, and I'm, oh, here, let's go grab the pot. I can remember back in the beginning. Back in the beginning. And I had next to nothing for backstock inventory or parts or anything. Jeez, that was a couple thousand amps ago. Both sides of the street. You guys know that my mind is divided into two different sides of the street. We have new build projects, and then we have the old, or not old, but the repair side of the business, which is a completely separate entity in my mind because of the way they pay for each other. Like the new build side of the business is completely separate money-wise from the repair side of the business. So they're two separate universes in my mind. So you repair a little bit, do a couple new builds, repair a little bit, do a couple new builds, repair a little bit, do a couple new builds. I think you guys are getting the theme of things here around here. So just remember back in the beginning thinking, God, if I could just get where I have X amount of dollars in parts on the shelf. Let's have one of my students, old Mr. Scorpion over there at Scorpion Repair. We were talking the other day about money and how much money you need to keep in your account and how much money you need to keep in all your parts on the shelf. And his brain was just like, I could hear him on his side of the street going, whoa, when it come to parts. It is absolutely mind-boggling when you have to start from zero and then upstretch yourself to where you've got parts. So you tell these guys, you're not going to be able to pull a single penny out of your business probably the first 3 or 4 years because you're going to be reinvesting that money back into it for unobtainium parts. And I'm not saying this little rinky-dink ass fuse holder is, there it goes, now it's accepting the solder. This little rinky-dink ass fuse holder is an unobtainium part. But, and I got a whole room full of unobtainium parts I'm standing in at the moment. Okay, so, whoop whoop. I'll knock the foot over on the tripod. There we go. Let's flip this puppy over and see what we got going on the top side. What do you think? This thing's virgin on the inside. It's clean. I mean, this thing's clean on the inside. Wonder what Mr. Earl's problem was here with this thing. The note that I received with this thing was, that's it. I told you everything I learned in the note. Let's move this out of the way and let's take a quick look at the tubes real fast. Give me just a second, I gotta reset up for that. This old girl come to me from the high desert. I had to take it all apart and recap it and clean it. This is a very vital piece of equipment. This is my B&K model 747 tube tester, which I'm pretty sure in my lifetime will become a thing of the past. Oh man, he had them packed where they were laying like this on each other. Or Sylvanias. And an RCA. Anyhow, I had a good friend of mine find this for me. He scored on this because it was broken. The tester, that is. And I was able to get the thing running. Makes me happy. 6LX6. It's going to go in this socket right here. No. It's going to go right here. Can't remember. I'm going to take the heater and I think I go to 6 with it. Get out my little book here. Oh, this book here. 6 here. Sensitivity at 80. Socket, yep, 29. So this is going to be C, D. No. 0. And this is going to be Z. So the only difference between this tube and like an 8950 is going to be filament. No, I'd have to go look at the data sheet because that would mean the grid dissipation was different. Let's turn this on and give it a minute. The thing with testing tubes is you don't want to get in a hurry about anything. Nice and slow. Slow. Oh, what was that phrase we used to use when I was in school back in the day? Slow is smooth. Smooth is fast. Slow is fast. So we don't get in a hurry about nothing. So what we're waiting for the filament to do inside this thing is chooch. Okay. Wait for the filament to heat and us get some electron flow moving up through the tube. I'm gonna grab my brand new Sharpie here. Got no shorts, no grid emissions problems. Woo! Recheck that. It's way too high in the sensitivity. This is why I like working on things at night. I literally spent most of yesterday on the phone. Oh. Put that right at 47. That would explain some things. Test 1. Test 2, no problems. No grid emission shorts and no output shorts. Okay. 70% on that one. It's a badass tube tester, so test everything from an 8950 down to the little peanut tubes that drive TVs. And it's even got a transistor checker, if I wanted to use it in that way. So, no shorts, no grid problems. And now we're going to watch the tube come up in temp, which I don't want to stand on that. We'll let the tube do its own thing. Made by Dynajet. Solid state dynamic multi-conductance tube tester. Project at Dyscan Corporation. 1801 West Bella Plain Avenue, Chicago, Illinois. Oh, this isn't looking good. It's in the high voltage rectifier range, but I'll say 50. That's what we're going to do with this one. 50. So the Sylvania is the best one so far. Had this friend that had one of these, and he was passing through town, and the guy that I used to work with back in the day, we had a bunch of 8950 tubes, and we had no means to test them, right? I mean, we're talking like a Tupperware box full of 8950 tubes. And I sat there and I watched him test every single one of those tubes. I couldn't believe the guy was out on vacation, and in his RV he had one of these as a tube tester. I was thinking, Jesus, you got radio to the marrow of your bones, man. If you're going out on vacation with your family, it's 60 also. Vacation with your family for the summer, and you're carrying around a tube tester. That's shit. He says to me, he goes, you never know when the deal's going to show up. And this is back before I knew anything or was doing anything or had anything going down. So I'm now with him in that same train of thought. I'm just too lazy to pack the tube tester around with me. I'm like, well, send me the damn tubes. I'll check them out for you. But anyhow, I had this 747, and as he was sitting there testing the tubes, I was going through the book, and I was like, man, this thing tests like every goddamn thing. So when I became a man and I put away childish things and started to think like a man and conduct myself like a man, I made it a goal to get myself one of these. This is 15 years later, right? So, I mean, I just cringe to think how many of these were thrown into landfills because nobody's like, oh, tube, who would ever want to use a tube tester? Nothing. Man, these are all on the bottom end of output. This is up at 60 also. But we got no shorts. We got no shorts in our shorts. All right. Let's put this away and then we'll get the amp back out. Let's see. Let's run through our high voltage section because usually that's what's the problem with the box. Is the electrolytics in the high voltage section dry out. 5.0, 5.50, 5.50, 5.50. Okay, so I've got the same leakage across. So let's turn it on. Let's turn it on, but without the tubes. Let's check ourselves some voltages here. So, I don't see anything that's going to give me enough pause to where I need to be concerned about the thing exploding. So put power to it. This is called a Variac, by the way. They come in all shapes and sizes, but everybody goes, oh, Variac, it's a variable resistor. Wrong. It is a variable voltage transformer. Big difference. Big difference. And if I could ever get any free time, which I don't think people ever get in their head, that I don't have free time, and like they're always running around thinking of it's like a party over here or something. I don't know, but I got this little guy that I've got to put in a cabinet. This is, let's see, what is this thing? It's a 25 amp, 240 volt. This is a 25 amp continuous, 240 volt. Center tap, overvolt 40, undervolt 40. So I can go negative 40 volts low, negative 40 volts high. So this is almost a 300 volt Variac that I purchased from a guy. And I got this just so I could work on SP220s and Henrys. So I didn't have to go through the pain in the ass of pain in the ass of changing them down to 110 to bring them up on this little guy. But if I ever get a minute, I'd put this 40-pound bitch inside of a cabinet. And mount that thing permanently underneath the bench. Okay. One of my most valuable tools I own. My high voltage probe. Even though in my mind's eye, the 600 to 900 volts that could be present inside of this little guy is relatively low voltage. I don't feel like shocking myself on camera today, so we'll get out our voltage meter. We're going to watch a couple things as this thing turns on. So, I remember the first time any of the radio guys I was hanging around with, they're all like, "You need a variac." And I'm like, "A what?" And they're like, "A variac. It's this neat thing that you can turn, plug your thing into and turn on, and sit there and you can watch stuff break down if there's a problem instead of just turning it short." And I was like, "Whoa, what is that?" Remember, guys, none of us was born knowing any and everything. Okay? We all came out of our moms the same way, and we all had to go through the same public school system the same way, and we all put our pants on the same way. So when I say I can remember, we're not talking about last week or even 5 years ago. We're talking like 20 years ago. And I was like, a variac? What is that? So, let's see. What is the one thing I forgot to do? Off. I don't know what that fuse value is, but it is too low for our purposes. That doesn't even have a fuse in it. Nice. Nice. Yeah, I'm getting thin in the fuse department. Jeez. Must have been breaking some shit here lately. It's alright. I got a Chinesium freight directly across the street. I'll be just fine. So I phoned with one of my tech buddies the other day and he ran out of zip ties. It's like, how can that be? It's like you wake up and buy zip ties, you know? Alright, so amplifier on, we're going to put it in the operate while. Let's put it in standby mode. High power, preamp off. Let's see if we can even turn on. Now, this is a skill in itself, turning this knob. Because what you're feeling for is you can feel as you stack the voltage on the device, you can feel the resistance in the variable transformer. It gets a whole different texture to it. Jesus, that's the best little one of them fans I've ever seen. Okay, we're going to run at about 105 because I know my line voltage going into that's about 120. Cool, we got our filament volts. 66 volts, 34, 30. Really. Okay. I feel comfortable with putting tubes in it. Everything looks good. There's a lot of little safety procedures that take place off camera that you guys don't ever get to see. Like, right now this thing isn't plugged in. Verified the high voltage was bled down with the probe. And since I only trust the probe so far, I physically come in and crowbar the circuit. And I have several screwdrivers I use for that, depending on their length. Now, I don't trust this handle as having any kind of insulation property to it whatsoever. That's why I believe the meter system, but then I have to ground it for a mental thing. When I was building power lines, there was a certain set of procedures they made you just do. They ground them into your brain, right? So that gets carried over to this day. It's not grounded till it's dead and grounded, but I mean, I got high voltage gloves and the whole 9 yards over here. And trust me when I say this, and believe me when I say this, I use them. Okay. Let's got our tubes back in it. I'll slide this over here where you guys can see it a little bit more. Let me grab my Variac one more time. We know we've tested those tubes. Until we actually put them underneath a full load of operation, I can't guarantee that they're actually really any good. Tube tester is a general tool, things might change. So, let's see if we can get some filament light out of this thing. Helps if it's on, right? There goes our fan. I swear to God, that thing's moving more air than I've ever seen come out of one of them tiny little brushless fans. The real test is when we put this thing in operation, because this box works on a switched high voltage circuit. So there's no high voltage that's present up here at all until we go into transmission. Click. Which, tomato, there's some pros and there's some cons to operating the amplifier like that. Thank you, little red devil. All right. Let's see what happens when we go into operation. So remember, this is an incredibly low drive device. Okay, so we're going to put 25, 30 watts in it at the most. Nope. At the most. Now you guys seen, as soon as I plug that in, all of a sudden it's down to one hand operations. This other hand is actually over here in my pocket. We do that for safety. We don't want to give yourself the opportunity to have any kind of voltage cross your heart, as we all know. Okay. Ooh. I got nothing going through the amplifier. Nothing. Alright. Didn't even get to the transmit portion of things. Just the ability to have RF come in one connector and go out the other, not happening. Which is usually a relay issue. But I've had it on older stuff be a coax issue. I've had it be all kinds of crazy things. The capacitor on the freaking key and circuit go south. Having good dreams over there, old man? Hmm? Found a problem already. It looked good from afar, but once we get up close, we found it was no good. Alright, let me get this thing fixed up. Really? You don't want to focus? That's 4 feet from you is unfocusable. $2,800 camera. Okay, we'll be back. So now, I could have just taken that stock hardcore wire that was in there. Solid core wire. And just slobbed it right over on the pin. But then that would have made the wire bowstring tight, and then probably within 6 months, maybe a year if I was lucky, you'd have been calling back over here with the same problem. Can't talk through the amp, or it won't put out nothing. That son of a bitch come off there. I know, it's the 1960s unobtainium solder that has got flux to nickel titanium in it and shit. There. That's what we were looking for. So once again, now I can see what I'm doing. That little tiny wire is what we're after. Right there. So here's our old solid core, right? And here's our new solid core. There we go. So, just one more little sucker of the solder here. What we're after is there's a physical opening in the little tab, and I want to go in and I want to make a mechanical connection because that's the proper way to do it. So we'll go in here, you hoop the tab, you hoop a wire through the tab, right? And you bend it over. That way if for some reason your solder work is inadequate, you still have a connection. Yowzer. I can't coil this because that would be bad. Bad, right? But what I can do is put a little physical slack in it. Come in. Here we go. And you never want to have like real hard edges. There's another electrical process that takes place with hard edges and hard bends in RF wire, because RF remembers AC. We want to avoid. Okay. Take that old wire and we're going to throw it away. See, now that's not bowstring tight. And we've got a round bend, and then another round bend. So we've got a little bit of room for expansion and contraction going on. I'll bet we can talk through this now. Hello. Look at that, Pepper. Hello. Alright, we're getting our 10 watts through it. Since that's on the output side, that might explain why we ain't getting nothing out of it. Hello. Nice. Hello. Well, it's definitely got more problems than a broken wire. Yes, sir. Schematics. So what I'm sitting here doing is building this thing in my mind, right? So this is our high voltage relay. This is going to be our primary transmit receive relay. It's driven off of this transistor over here in the corner. This is our preamp board, which uses a 2N222 switching transistor, by the way, and it is burnt. So I'm thinking when this wire broke, the RF might have backfed and blew this up. That has nothing to do why this thing won't go into transmit. I have a feeling that this isn't the appropriate transistor that's supposed to be over here. So the operate standby circuit comes from this diode here. Comes from this diode here, which gives us about 15-16 volts rectified. Comes in on the switch here, goes out on the switch here, so we've got current to here. So then we have a low voltage circuit that comes over here to the sideband switch, but that's run off of this transistor. So our preamp circuit, which is here, which is our gray wire, now that we're in operate, my voltage here, which will drop the 15 volts to here, then it goes to this reduction diode. Okay, it drops it from 17 to 14 volts. And we've got our input voltage. Okay. So coil goes to that contact, comes out, goes to the ground wire. Fun, right? The life of an amp repair guy. Okay. So the way this works is the RF comes in, passes by this capacitor. It weeps just a little bit of energy by, and it's going to key this transistor. This whole thing runs on a switch ground, okay? So you got your ground reference, your output, and then you're going to have your actual drop lead, okay? So you're going to have your reference voltage. So the RF comes in, it's going to charge the center leg of the transistor, and it's going to cause it to flop to ground, okay? Orange wire takes off, runs over here. Runs over here to the high volt relay, which will ground the high volt relay. Now we've got our 12 volt drop from our operate standby on the other side of the high volt relay, so they're going to bring the high volt relay on first, which makes sense. They're using one half of the relay to actually flop the high voltage, then they're using the other half of the relay to kick the 12 volt. So we've got the wire loop, the power comes in, loops through this relay, comes back out, and then it in turn kicks, if the preamp is on, it in turn kicks the preamp out, because the relay is going to stay in the operate position till this relay fires, kicks this relay out, and drops this one into operate mode. That's the wrong transistor, and it's in there wrong. Yep. Okay. Let me fix this. So this is pretty simple as soon as I got my head wrapped around it. Over here on this relay here, is leaking voltage across. And it was showing too much ground potential across the coil. So what I did to help neutralize that is there's a diode that I added down in here across the terminal legs of the, there's a little diode, a little protection diode that I added across the terminal legs of the relay. And when I did that, it helped neutralize the whole circuit. Because, you know, a diode's kind of like a check valve of the universe, the electronic world that we live in. And once I did that, the keying circuit came into operation. Now, I don't know what transistor was supposed to be in here. I took a couple seconds and looked on the old interboob and could not find a schematic for it. Literally just took a couple minutes, like 2. And went, oh well, I know how to make this work since it's a negative switch circuit. So I went ahead and modified the keying circuit in the back. This now uses a 2N222 standard, simple keying transistor. This is your sideband delay, this white and brown wire. That's repaired. I went ahead and I took apart your preamp circuit. It had that burned up resistor that was on it, and it was keeping the transistor from coming in and turning on and doing any kind of rectification. That transistor was popped. So the other thing is the input capacitor. This 120 puff had gone to a complete dead short. This little guy. It sits right about there. So I went ahead and I replaced that. And then down here I added a little bit of capacitance to your input tune to get it to lay down perfectly flat. It was pretty close. I think it'd be better as if you had a new tube in there, but it was pretty close. So I added just about 100 puff worth of capacitance to it and it laid down flat. Okay, so your pass-through tune's fixed, the output wire's fixed, the keying circuit is repaired, the tubes have been tested, the preamp is repaired, the sideband circuit has been repaired. Somebody that had been in here and had put this transistor in there as a keying transistor, which was the wrong one because it's a PMP. They'd moved the sideband delay and they'd put it to the center leg. Let's see, emitter base collector, to the center leg of the keying transistor, which is the wrong place to put it. That actually affects your input quite a bit. So we went ahead and moved it over to the appropriate spot, which is on the, base. The base leg, the output leg of this thing. So Yeah, it works. Just like that. And we didn't tear the whole amp to do it. Tear the whole guts of this thing up to do it. Pretty straightforward. Yeah. Give me just a second. Let me take the camera off tripod. So I went ahead and cleaned all the burn off here. And that resistor was so burned up I couldn't read the values on it. But just from a couple years of looking at these, I assumed it was somewhere in the 470, 480 ohm range all the way to about the 700 ohm range. So I went for the low ball resistor. And then I changed this out to a different transistor than what was in there. They had a 2N222, which if you look at the op amp principles of a 2N222, you'll see that it creates about 5 dBs worth of noise on the noise floor versus its input signal. So it's a horrible transistor to use as an amplifying device. So I put a different transistor in there that's got almost a -20 down in noise floor amplification for the preamp. The preamp is now working. I want to show you this diode that I added over here. That's it. Let me put the bottom on it. I'm going to flip it over and let's go play on the top side. But I'm pretty sure there's nothing I'm going to have to do up there. I'm not going to have to do anything up here. Just turn this on and go into the operate mode. And I am klutzing all over the place this morning. I'll explain it. Coax connector's loose. Okay. Turn this thing on. Now I'm going to go into operate. I'm going to kick on the receive amp. You're going to notice about a 5 dB increase when you use the preamp. As far as your receive signal goes, 4 to 5 dB increase, but you're not going to notice hardly any noise floor increase. So, is what it is. The only thing I need to look at on this side is to make sure our meter is actually moving. From playing with it, making sure it's all working before we got this far on video. I know that this thing is working fairly well. If you had 3 new final tubes in this thing that were all above 50-60%, you would probably see 850 plus watts out of this thing with a modern 30-watt radio driving it. So, let me zoom in here a little bit. And what we're looking at, guys, is that's a 1,000 watt slug and peak, 1,000 in average, 5 watt slug and reverse. On high. Hello. Hello. Tubes warm up. It's pretty cool in here right now. So those fans are, that fan is, man, I've never seen one of them little fans turn that fast, move that much air. Meter's working as it should. And that's all we're putting into it for drive, you guys, about 10 whole watts. So, on that note, I think we're pretty good. Oh, loudmouth, man. I'll get in here and show you this one more time. So this is all I'm putting into it for drive. Next to nothing, right? 750. 700 watts, 600 watts. Spend an hour trying to get 2 more watts out of it, or I can tune it in for 650 to 700 watts and leave it. That's on high. Let's go on down here to low. High power, low power. Back to high power. About 500 on low. It's working, man. Just the way it should. It's a cute little amp. It's in really good shape for as old as it is. I mean, on the inside, this thing is pristine. I was looking at the outside of the cabinet of this thing, and it's a little rough. It's got a couple spots of rust on it, and the outside of it's a little dirty, but inside this thing is... Look at this. It's one of the cleanest sweep tube amps I've ever had here in a while. Oh, not that I've ever had, but one of the cleanest sweep tubes I've had here in a long time. So, but guys, that's it. That's it. That's all. I'm done. I'm done twiddling around with this thing. I'm gonna move on to bigger and better, different kind of other shit. So, look. If you guys like what you see, right? You're going, wow, you can literally fix anything. Maybe that hunk of junk that's sitting in my closet, I need to get it repaired. That's great. Send it here. I'll take care of you. But guys, do me a favor, please. I've got probably 24 amplifiers here now that I would love to repair, but I don't have any contact information for the people. So if you haven't heard from me in like 7 months and your amp's been sitting here, it's probably because you forgot to put a piece of paper with the amplifier and your phone number on it. So please give me a minute and just reach out, call me, talk to me, give me your contact information. That way I can go ahead and put those amps back in rotation. I can get them the hell out of here. It's no joke. I've probably got 24 boxes that I have no idea who they belong to, because I didn't get any contact information, or I didn't get a phone number, or we're not friends on Facebook. So I have no means to be able to reach you. So if you send me anything, please, for the love of God, just take a couple seconds, put down your name, your phone number, and your address on a piece of paper. Just take it, slap it literally on top of the amplifier inside the box. So when I open the amp up, I go, oh, look, here it is. It's that simple. It'd help me a ton. It'd help me a ton. It's like, well, for prime example, let me cover this up. This guy's address and so forth. This is what I got from this guy. I got nothing. This is what I had to cut off the outside of the box so I'd have at least something, so I'd have his name, covering his name up. I got no phone numbers. I got no contact information on this one. And if it wasn't for this guy calling me the last couple weeks, it would have continued to sit there until I heard from somebody about it. I'm not going to go and repair the amp and then just sit on it. So, like I said, gentlemen, please, if you're going to send me something, take 5 seconds, put your name with the amplifier and a phone number. I greatly appreciate it. The first time you're ever watching this channel, which I highly doubt it, but if it is, take 1 second, click subscribe. Okay, I got to go. I'm going to slap the tin on this thing first. I'm going to let the tubes cool off, pull them out, put them back into a packing, and this thing's out of here. Mr. Earl, we'll be calling you later on today, but brother, your amplifier is done. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. I'll see ya. Bye.